We're going to start out with an example. We're talking about exponents now. And do you guys remember what exponents actually mean? It's been a while, I'm sure. Okay, so exponents mean that you're multiplying something over and over again. Okay, so where'd my markers go? A cubed means, so this part means A times A times A. That's what that part means. You're going to multiply A by itself 3 times. And then this one, what do you think that one means?
2 times.
A times A. So if we think about how many A's do we have, because these parentheses,
5.
since it's all multiplying, do the parentheses do anything here?
No.
No, it's just A times A times A times A times A. So we end up with 5 A's all multiplied together. And if we wrote that as an exponent, it would say A to the 5th power. Right? Does that make sense?
A to the 5th.
That's using the definition. That's using the definition of what exponents mean. But if we had to write out all these A's every time, like what if we had A to the 32nd power? Do I want to write out 32 A's? No, I do not. So what we want to do is we want to think of some rules. So what do you see?
3.
This tells you how many A's in the first group. This tells you how many A's in the second group. This tells us how many A's altogether. So how do you think we got from this to this?
3 plus 2.
We added the 2 exponents together because we've got a group of 3 and a group of 2. We add them together and we get a group of 5. Does that make sense?
Mm-hmm. Yes.
And if you look right underneath that example, you're going to see our rule for if you multiply 2 numbers, two numbers that have the same base and they each have exponents, that base stays the same, and all we do is we add the exponents together. So for our example, it was 3 plus 2 equaled 5. Does that make sense?
Yes.
So we're going to do an example, and we're not going to simplify it. I should have probably just left it with variables, but we're not going to simplify it. But we're going to do an example right here, and we've got 3 of them. So I'm not going to write out a whole bunch of 3s. We're just going to use the rule. Now, before we use this rule, what is the exponent automatically on this 3 that doesn't have anything written next to it?
1.
It's automatically 1, because if there's nothing written, there's just one of them there, right? So this means I've got 2 3s, I've got 6 3s, I've got 1 more 3, and all we have to do is add those exponents together to see how many 3s we have all together, right? So 3 is still the base. I've got 2 of them here. Now I've got 6, so I've got 8, and this gives me 9. So 3 to the 9th power. Now with a number, you could actually do that and get a really big number. We're not worried about that. Most of the ones we deal with are going to be variables. Okay. So does that make sense? We can do these 2.
Mm-hmm.
This would be 3 to the 8th power. And then we do these 2, and we get 3 to the 9th power.
So you're not multiplying 3 times 3, then 3 times 3, then 3.
I mean, you can think about it that way, but we're just trying to get the,
Easy
I mean,
way.
yes, we've got, if you wrote out the definition, it's this times this times this. And so we do have 9 of them, but that's the whole point is we can use our rule and say, all I have to do is add the exponents up. So 2 plus 6 is 8, plus 1 more is 9. It's going to equal 3 to the 9th power. Okay, so that's where we get to use our rule to help us out with that. All right, now let's do this one. It looks more complicated because there's other stuff here. Now we're going to do one piece at a time. So we start out with the numbers. And we're actually just going to multiply the numbers. So 2 times 5 is what? 10. So we get to write down our 10. Then we've got, let's see, let's circle this in green just to differentiate. So we've got x cubed. And these are all multiplied, right? Do we remember that if there's no signs in between, it's automatically multiplied? So x cubed times x is going to give us x to what power?
4.
3 plus
1.
1, right? So it's going to be a 4.
Mm-hmm.
Does that make sense?
Yes.
Okay. Then if we look at this one, the y's, y to the 5th times y squared will be y to the 7th. And then finally, we've got this z, which means z to the first, and then this z to the third, and that's going to be z to the fourth. And you just do one letter at a time, and then you're done. And that's our answer. Okay. And there's not any simplifying unless you've got multiple letters that are the same, which we don't. That's why we just do all the letters at one time and we get it done. Okay. Does that make sense? The only thing that we're going to be able to really do too much with is the numbers. You can multiply the numbers together. Otherwise, you're just changing the exponents. Okay. Are we okay to go on? All right. So let's do this one. And again, let's go back to our definition because now we're not multiplying anymore. Now we are dividing, right? So what does the top one, using the definition, what does the top mean if we have a to the fifth power? 5 a's multiplied together. So a times a times a times a times a. And what does the bottom mean? 2 a's. Okay. Does that make sense so far? Now, I don't know if you remember this, like reducing numbers. But if you got a factor on the top that matches up with a factor on the bottom, you can divide them and they become ones, right? A divided by a is 1. And can't that happen again? And so now my denominator's all gone. It's just 1. And what do I have left? How would I write that using exponents?
5 minus a power 5
A.
minus 2
Well, it'd be a to the
to the 5
third. Okay. Now, again, if we think about this, if we think about these exponents that we have right here, 5 and 2, how do we get from a to the fifth divided by a to the second and end up with a cubed? And I think we subtract them, right? Because what's happening is the 2 on the bottom cancel with 2 of the ones on the top, so they're subtracting them out. And so that's going to be our rule here for this one is when we have exponents, or actually 2 numbers that both have the same base again, they have to be the same base, and they have exponents, we subtract the exponents. Now, the way I do it is I always take the bigger one minus the smaller one, and we're going to see how that works in a minute. But for now, most of the time, the bigger one's going to be on the top, the smaller one will be on the bottom. But we'll look at some examples that aren't like that and see what happens with those. If you just think about it, if there are more on the bottom than on the top, and you think about canceling, where are they going to end up being still? So let me give you an example. So if we had b times b times b on the top, and b times b times b times b times b times b times b on the bottom, where they're going to end up, I shouldn't have chosen b's. I was going to say where are they going to end up being. Okay. So if we cancel this one with this one, this one with this one, this one, and this one, do you see that there are still b's left on the bottom and the top is a 1? So we would end up with 1 over, I've got 4 here, b to the fourth. So that could happen if there are more on the bottom than there are on the top. Okay, in our first example, there were more on the top than there were on the bottom.
And can we move that, right? B to the power minus 1.
We're going to talk about that, yeah.
Oh, okay.
That won't be tonight, though. That'll be next week. Okay, so let's simplify this one. Again, we're going to leave it in exponent form. I don't know why I use numbers. I just copied their examples, and I should have just changed the variables. So if we want this to be a base of 7, because they both have a base of 7, and I've got 13 7s on the top and 5 7s on the bottom, after I think about canceling them, or I think about using my subtraction rule, what am I going to end up with? 7 to what power?
8.
7 to the 8th power. And how did you get that?
I subtracted 5 from
Yeah.
13.
13 minus 5, right? If you think about canceling, 5 of them cancel. So you've got 8 left. If you just use the subtraction rule, 13 minus 5 is 8. Does that make sense? Okay. So let's do another one, kind of like the last one. Now, the numbers here, we want to do them, we're going to do them each, again, one at a time. If I take 5 divided by 2, can I really do anything there as far as simplifying? No. So this is just going to stay as 5 on the top and 2 on the bottom. Now, here we have a cubed on the top and a, remember that's a to the first power on the bottom. So what's going to happen there?
3 minus 1.
3 minus 1. And so we'll have a squared. Will it be on the top or on the bottom?
Top.
It'll be on the top because you had more a's on the top. Does that make sense? Now let's look at the b's. We've got b to the 5th and b cubed. When we look at that, how many b's will be left? 2, so it'll be b squared. And is it going to be the b's on the top or the b's on the bottom? On the top, because there are more on the top. So b squared. And then we have c squared on the top and c on the bottom. And remember that's c to the first. So what are we going to be left with? C on the top or on the bottom? Top. So in this case, the 2 is the only thing left on the bottom, and we have 5a squared b squared c on the top. Now, one thing that I will mention, and you'll see this sometimes, so just so that you know, this can also be written as 5 halves a squared b squared c. You might just see the a squared, b squared, and c written off to the side, and the number part as a fraction. So they both mean the same thing, and I'm okay with either one of them.
So you simplify, do you need to simplify the numbers or just leave like that?
What do you mean? Like this is okay or this is okay?
I mean, like 5 by 2. Do you want us to simplify like 2 by 5? Or?
No, we don't want to mix. We don't want to mix decimals and fractions together. So, because we could end up over here, we could easily end up with fractions, and so we would rather just leave
But
it
you
as
want a cancellation, right?
you reduce if we can. Yeah, if you had 10 over 4, yeah, you reduce it. Okay, are we okay with that one? All right. So here's another option. Now let's use our definition and see if we can do this one. And we'll try and just use part of the definition. What does it mean to cube something?
Multiply 3 times.
Multiply by itself 3 times. So we're taking a squared times a squared times a squared, right? Does that make sense?
Yes.
Now, we can use a rule that we already learned here, right? We are multiplying things that all have the same base. What do we do with those exponents?
Multiply.
Add them. We add them. So this will be a to the 6th. Okay? Now, going back to here and looking at these, what's the relationship between these and this?
2 times 3 equals 6.
2 times 3. Does that make sense? We've got a group of 2, but we're going to have 3 groups of 2. So you end up with 6. And so the rule, now this is, you got to be careful here. The first rule we learned was this one. A to the m times a to the n equals a to the m plus n. Okay? That's where you have 2 different numbers with the same base, and they each have exponents. Right? That was the first rule. Here, we only have 1 base. Right? You see there's only 1 base here, and that 1 base has 2 exponents attached to it. That's when you're going to multiply. Here, when there's 2 separate bases that are the same, you're going to add. So this one right here and this rule that we're talking about right here, those are the ones that tend to get mixed up because they kind of look similar. But if you pay attention to the fact that here you've got 2 separate numbers, each raised to a power, and here you've got just 1 number raised to a power twice, I'll usually say power of a power, right? That's where you're going to multiply them. Okay? It will always have the parentheses on it. Yep. In order to do that, you've got to have the parentheses on it. So here's the rule for power of a power rule for exponents. And notice the rule is if you've got a raised to a power and then that is also raised to a power, you multiply the 2 exponents together, m times n. M times n. Okay? So let's do an example like that. And this one isn't too bad. We just used the rule. So notice one base, two exponents. It's going to be a to what power for our answer? 15. And again, if you need to go back to the definition, because these are all pretty easy to go back to the definition, it means I've got a group of 5, but I've got 3 groups of 5, right? So I'm going to have 15 altogether. That's why we multiply them. Are we good to go on? All right. Here's another one that we want to go back to our definition on. Again, what does it mean to cube something? Multiply by itself. And I'm not even going to put parentheses here. So we're multiplying AB times AB times AB, correct? So I don't know if you remember this, but we had some nice rules for multiplication. The rules were the order doesn't matter when you multiply, and that you can rearrange them when you multiply. This is all the way back to probably the 0 chapter that some of us practiced and some of us maybe didn't practice as much, but it's the same. It's those properties. So what we can do is we can rearrange these and we can put all the A's together at the beginning and all the B's together at the end. And then how many A's do we end up with?
3.
Or even right here, you can see there are 3 A's, right? And how many B's do we end up with? 3. So what do you see happens when you got this product A times B raised to the 3rd power? What happens? The 3 applies to both the A and the B, right? Because multiplication, you can just rearrange. Okay. And that is going to be our next rule that we see right here. Now, this one, again, is something we have to be a little bit careful of, and I'll tell you why in a second. So our rule is if you've got a product and you raise it to a power, that exponent will just apply to both of those factors inside the parentheses. Again, there has to be parentheses here to use this. If there's no parentheses, then the m doesn't apply to both. It only applies to what it's right next to. Okay. So let's do another example like that. If we have 2x to the 4, 2x in parentheses raised to the 4th, what does that mean we're going to do? 2 gets raised to what power?
To
the 4th. And x gets raised to what power?
the 4th.
The 4th. They both do. Now, again, with numbers, I don't know why I use numbers for those, but we can actually do this, right? 2 to the 4th means 2 times 2, which is what? Times 2 again.
8.
8 times 2 a 4th time. Gives us 16. So this becomes 16, and then x to the 4th. Now, you could use the definition, 2x times 2x times 2x times 2x, and then multiply all the 2's together and get 16, and then multiply the x's together and get x to the 4th. So you could do the definition. It's just unnecessary because we can use our rule. Okay? Now, like I said, this one is one we have to be a little bit careful of, and here's the reason. You can see it on your paper, but we have to be very careful. The difference between this and this, what is the difference between these two?
You're adding.
Plus.
In this one, there's a plus sign in between. These are not factors. They're not multiplied together. This is not true. This exponent right here does not just apply to the A and the B. That only works when it's all multiplication inside. If there's ever addition or subtraction, you can't use this rule. That's why I don't like using the word distribute the m to both of them, because remember what distribution means? It means you go through the parentheses to all the different terms. Okay, so I usually say that the m applies to both the A and the B. It's not distribution. Distribution is something different that we've done before, where we multiply through the parentheses. Okay, this is a very, 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 very common mistake that people make.
So if it is like that, how do we have to put the correct one?
Well,
Plus
I'll just give you a quick example. So if we had A plus B and it was squared, what that means is you have to actually do a plus b times a plus b. And we'll get into how you do that a little bit more in a future chapter. Actually, later on in chapter 5, I think. But we're not ready for that yet. So you maybe have done it before in your other classes, but we haven't done it yet, so we're not going to worry about it. Just make sure that you understand when we get to this point where we start putting the plus sign in there, this does not just apply to both of them and say, okay, magic, we're done. It actually takes some work. Okay? So very common mistake, and people make it a lot all the time if they're not paying attention. Okay, so we got to be careful with that. Now here's another one. Using our definition, again, what does it mean to cube something? Multiply it by itself 3 times. Now you may or may not remember fraction rules for multiplication, but we did them earlier, probably again in chapter 0. But the nice thing is when you multiply fractions, you multiply straight across. So a times a times a gives us a cubed. And then b times b times b gives us b cubed. Okay, so looking back at our example, what do you think happens this time when you've got this division and a power? Just like the multiplication one, the 3 applies to the a and the 3 applies to the b.
Mm-hmm.
And so you see, we're going to end up with that. And this is why, because you can see you're just going to have that many of them. Okay. Again, doesn't work for addition or subtraction, but multiplication and division is okay. So here's our rule for that. Quotient rule, power of a quotient. Quotient means you're dividing. So if you have a fraction, a quotient, a over b, and it's raised to the m power, the m just applies to the a, and the m applies to the b. Okay. So these rules, and I do want to be a little bit careful, these rules are all very simple when you're doing one thing at a time. What happens is, though, eventually we get to problems that are, you're doing a whole bunch of things at one time. And so you have to just make sure you just try to do one thing at a time. Because each of the individual rules is easy. But when we try to do a whole bunch of stuff at once, that's where it gets more complicated. All right, are we okay with that? So let's take a look at an example. All right. So we are actually putting 2 rules together here because we have multiplication and we have division, right?
Mm-hmm.
So what do you think is going to happen here according to our last 2 rules that we've talked about? We're obviously going to have an x, and we're obviously going to have a y, and we're obviously going to have a z. What power do you think should go with the x? A 5. What power do you think should go with the y? A 5. And what power do you think should go with the z? 5. So this top one is using the product rule, right? And then the bottom one is using the fact that we've got a quotient. So we can put those rules together. And that one's not too bad because the product rule and the quotient rule work the same way. The 5 just applies to everything that's in here. Okay? Does that make sense? She's like, I gotta get home. I'm falling asleep.
I'm so tired.
I'm so tired. Okay.
I'm
So,
sorry.
no, it's okay. Believe me, I have students in school first hour of the day, and they're like, why am I here? Why am I even trying to be awake?
I'm a morning person.
I am too. So. All right. That's why this night is really tough for me because I get up at 5 in the morning. And so when I stay up till 10 o'clock at night and then have to drive home, I'm like, I'm so tired. I need Dr. Pepper.
Yeah.
Okay.
I get up around 4:30. And just wake up.
I just go over to school and just sleep there.
Yeah.
My wife might not be happy about that.
Yeah.
Okay. Looking at this one, now this is where we start combining things, right? Because we've got, it's not just an x and a y and a z or whatever inside. There's x to a power and y not to a power and z to a power. But here's what we're going to do. We're going to use, it's this times this, right? So this is our product rule. So here's what that means. X cubed, the 4 applies to the x cubed. Does that make sense? And then y, the 4 applies to the y.
And it would change if it had a plus inside,
Yes.
right? Okay.
And then the z squared, the 4 applies to that.
Okay.
Does that make sense that the 4 applies to everything inside of there?
Mm-hmm. if it's plus, like you have to plus.
Okay,
first and-
So the 4 applies to the x cubed, because again, these are grouped. The x cubed is one thing, the y is the next thing. Each letter is its own individual thing, right? So the 4 applies to the x cubed, the 4 applies to the y, the 4 applies to the z squared. Okay, now we have to go back a couple rules ago, right? Because now we have 2 powers attached to this x. What do we do with those 2 powers? What is this going to end up being? X to the what?
12.
12. Because remember our rule, you might have to look back, but the rule is we're going to multiply them together. So x to the 12th. Now this one's an easy one because there was no exponent there in the first place, so this is just
Oh,
y to the 4th.
1 to the 4.
Okay, and what about the z squared? So it's a z raised to the 2nd power and then also raised to the 4th power. That will be z to the 8th. You multiply those exponents together. When you have one base and 2 powers, you multiply them together. And then that would be your answer. So when you're all done, each letter should just be there one time and should have only one exponent. Okay? If you ever have like more than one x, you need to somehow put them together.
How would you put them together? Like 2?
Like if you had x squared times x to the 3rd, we'd use that rule of,
Oh. yeah.
right? Does that make sense? So when we're done, we should just have one x and one
Yeah.
y and one z and only one exponent with each thing. Okay? So that's when we say simplify, that's what we're saying. We want to make sure there's just one of each thing and one number, which might be a fraction. All right, so let's continue on here with some other things that are combinations. So notice we have times and divided by, but we've got multiplication and division, right? So what's the first thing that happens here? What do we know about this 2?
Multiply.
It applies to everything inside here, right?
Mhm.
So we're going to have a cubed gets squared, and then b gets squared, and then c to the 8th power gets squared, and d to the 10th power gets squared. Does that make sense? Did I copy something wrong? Okay, you were just looking at it like I had something wrong in the paper. So.
I mean, I compare.
Oh, so, and I'm doing every step here because I don't want anybody to think of, eventually as you get used to these, you're going to probably skip this step and you're going to say, I know these multiply together. Oh, I just gave it away. What are we going to do with the a cubed squared? We're going to multiply them together. We get a to the 6th. And then this one is just b to the 2nd. And on the bottom, c to the 8th squared will be what? C to the 16th. And then d to the 10th squared will become d to the 20th. Okay, so like I say, eventually, after you get used to doing these, you'll be like, oh, well, I know this 2 multiplies by the 3, and that'll be a to the 6th. I know that this becomes b squared. I know that this 2 multiplies by the 8 and becomes c to the 16th. But I don't want to overwhelm you with that right away. I would say just try one step at a time because, like I said, each individual step is really easy. It's when we try and do a whole bunch of things at once that it gets a little bit more complicated. And not that you won't get to that point where you can do that, but I don't want to have you trying to do that right away, especially until we have all the rules. Okay, so are we okay with example 207? All right. Now, how about this one? This one's kind of a repeat of a couple examples ago. What are we going to do?
Not distribute.
The 3 applies to everything on the inside, right? I'm not going to get mad at you for saying distribute. I just will try not to say it. Then we have x squared also gets cubed, and then we have y to the 5th also gets cubed. That 3 applies to everything on the inside because it's all multiplied. Now again, with numbers, we can actually simplify this, right? It is 4 cubed, but, and if you're not sure, you can use a calculator, but what is 4 times 4 times 4? Do you guys all know where your exponent button is on your calculator?
Mm-hmm.
You may want to grab your calculator and make sure that you can do it. So I'll just tell you, the answer is 64, but grab your calculators and make sure that you can do 4 cubed and get 64.
How do you type it?
So you're going to put in usually you'll put in the 4. And then usually there's a little, okay, yours is right here. There's an X with a little box above it. And then you're going to put in the 3 for cubed. And then close your parentheses, or you probably don't even have to close the parentheses. You hit enter, and you should get 364. But that's how you type it in. So it's that X with the box. Did you find yours?
Mm-hmm.
Got it? Okay. Did you find yours? Yours is not. Yours is going to be this little caret symbol right here. So you'll do 4, that caret symbol, and then 3. That tells you that the exponent is that. That's how you get the season.
We're so
Did you
quiet
find yours?
today.
You got it? Good.
Yeah, I think I'm tired too.
How about you? Did you get yours?
Great.
Perfect.
Just
All
want
right.
to eat.
Did you find yours?
No.
Okay. And yours looks different. Yours is this is the thing that tells you that it's going up into the exponent. So you just push that. It's called a caret symbol. And then you put in your 3 and hit enter. So that's telling you 4 raised to the 3rd. Okay. So if you got a number, make sure, and you might have to practice that. You'll probably have some time in your homework to practice that button. Okay. What happens with the X? What power will that end up being? I think you said it. But I could be wrong. 6, we multiply, right? And then what about the Y?
Actually, it should be 9 because 4x
15?
15.
This is the 15. Are you talking about this one?
Is it 2 or 8?
What?
Yep.
This one? What are we looking at? Okay. Are you looking at a different problem or what? She's working ahead. She's probably on like 3 problems from
Yeah.
now. Or do I have a typo on the paper?
Yeah, it's correct, but I did it wrong.
Oh, okay. Okay. Well, then I'm not going to worry about it. She can fix it. Okay, so does this make sense?
Yep.
Okay. So here are all of our rules kind of put together. First of all, we have, notice, 2 separate numbers that each have exponents, but the bases are the same. We add the exponents, right? That was the first one. Second one, if we're dividing 2 numbers that have the same bases and they both have exponents, we subtract the exponents. Okay. This one we've been doing a lot recently. 1 base with 2 exponents, multiply the exponents together. If we have a product, we've been doing this, the product, everything inside, the m applies to both of those. So you have a to the m and b to the m. And then same thing with the division. The m applies to both of those. You have a to the m divided by b to the m. Okay, so that's just a summary. So it's all in one place. If you ever need to go back and look, you know it's all right there. Otherwise, you have to look through like all the different sections. Okay, so it's all right there. For now, we're going to add some more in the next lesson. Oh, so what does this look like? So here's what I would suggest. I would suggest do the exact same thing we've been doing. What happens with that 3 on the outside? It applies to everything on the inside. So we're going to have 4. I'm not going to put the parentheses on the 4, but it's 4 cubed. And then x cubed is cubed. And then does it make sense? I don't need the parentheses on the y. It'll just be cubed. Y cubed cubed. Or sorry, y cubed. And then 5 is cubed. And then we have x to the 4th gets cubed. And then we have y squared gets cubed. Okay? Now, we just talked about that 4 cubed is 64. And then here, x cubed cubed is x to what power? 9. And then we have y to the 3rd times. Okay, use that calculator skill that you just attained. What is 5 cubed?
25.
That's 5 squared.
No.
125.
125.
I wrote down 2.
Up here.
Yeah.
125. And then x to the 4th cubed will be x to the 12th, 4 times 3. And then y squared cubed will be y to the 6th. Okay, now we're not done simplifying yet because, first of all, we've got 2 different numbers. So with your calculator, if you'd help me out, what is 64 times 125?
8,000.
8,000? Okay. Now, notice we have two x's, x to the 9th and x to the 12th. What do we get when we combine them into just x to 1 power? X to the 21st, because our rule says we add them, correct?
Mhm.
And then the last one is we've got y cubed and y to the 6th. And what do we get when we combine those?
9.
Y to the 9th. So this is our answer. But I have a question for you. Earlier in the year, we learned about grouping symbols, and we learned that when you have parentheses, if there's something you can do inside the parentheses, you should always do that first, right? You remember when we talked about that?
Yes.
So let's take another look at this. If we've got 4x cubed y times 5x to the 4th y squared cubed, maybe I should multiply the 4 times the 5 first. And what would that be? 20 inside the parentheses. And then if I've got the x cubed and the x to the 4th, what does that give us?
7.
X to the 7th. And then we've got a y and a y squared. What does that give us?
3.
Y cubed. All right. Well, now we've done the simplifying inside. Now what should we do with the 3?
Apply.
So 20 cubed, x to the 7th cubed, and y cubed. Cubed. So grab your calculators again. What is 20 cubed? It is 8,000. What is y to the 7th, or sorry, x to the 7th cubed? 21, and y cubed.
Less.
Does it make any difference?
No.
No. So sometimes one way will be faster and sometimes another way will be faster. I would say in general, I would suggest this one is usually going to be faster. But it's not always. So it's, okay. Usually I like to simplify inside the parentheses first, if I can, and then go from there. Does that make sense? Because then you have usually less exponents to work with and things like that. But are we okay that we get the same answer there? And that always happens. You always get the same answer as long as you follow the rules. Are we okay to go on? All right. Let's try this one. So looking at this, now, since we just did this, is there anything we can do inside the parentheses here?
No.
No. So this time, we don't even have to worry about that, right? Now, the next question is, what does this 3 apply to?
Everything inside the.
Everything inside the parentheses, right? It applies to the 2 and it applies to a to the 4th. It does not apply to the 7a cubed. Does that make sense? It only applies to what's inside the parentheses. So the 7a cubed just hangs out here for a minute. Then we're going to have 2 cubed and a to the 4th cubed. Does that make sense to everybody? So let's do some simplifying. 7a cubed, we still can't do anything with. What is 2 cubed?
8.
Close. 2 times 2 times 2, not 2 times 3. So you have to be careful. 2 times 2 times 2 is 8. And then what about a to the 4th cubed?
12.
A to the 12th. Okay, we're not done simplifying yet because we have 2 different numbers. So we multiply the number. This is all multiplied, right? 7 times a cubed times 8 times a to the 12th. So 7 times the 8 gives us 56. And then what about a cubed times a to the 12th? A to the 15th. Remember, you got a group of 3 and a group of 12? So a to the 15th. That's using that rule where we add the exponents, 3 plus 12. Okay. Now that's where sometimes you just need to take a breath and think about, okay, what rule do I need to use here? Because we've got a lot of different really easy rules, but you don't want to mix them up. Okay. Like that's what I said. Each rule by itself is really easy, but when you start moving them around, then you got to make sure you pay attention. Okay. Are we okay with that one? All right. So again, looking at this one, you don't see the grouping symbol, but if you remember, we talked about a division bar is actually a grouping symbol. So I would suggest the easiest way is simplify the top first and then work with the bottom. Okay. So if I do the numbers on the top, we've got 3 times 10. That gives us what? 30. We've got a cubed times a to the 4th. What does that give us?
A to the 7th.
A to the 7th. And then we've got this b and the b cubed. What does that give us? B to the 4th is correct. Then the bottom is just 2 a to the 4th and b squared. We aren't doing anything with that. There's nothing to do down there. Now, but the top is all simplified and the bottom's all simplified, let's go top to bottom. We do the numbers. 30 divided by 2 gives us 15. A to the 7th divided by a to the 4th. A cubed, right? Because you had 7 of them on the top and 4 on the bottom. If you think about canceling, there's 3 left on the top. And then b to the 4th divided by b squared. B to the 2nd. And again, once you've only got one number and one of each variable, then you know you're done. So that's our answer, 15a cubed b squared. Okay. And again, all of this only works because all of these on the top are just multiplied and all of them on the bottom are just multiplied. If you ever had addition or subtraction in there, then we can't do these things. It has to be all multiplication. Okay. On the numerator and denominator.
10 or 9? 10.
Normally we get, are you talking about what time class gets over?
10?
9:50. Do we need to stay until 9:50?
No.
No? Okay. I could maybe talk really slow and okay. So can we do anything as far as simplifying in the numerator? No. So we'll just write down 3m to the 8th and n to the 12th. Now in the denominator, we can do some simplifying, right? Not inside the parentheses, but we can take care of getting rid of that parentheses. So what happens with this 3 on the outside? It applies to all these things inside. So m squared gets cubed and n cubed gets cubed. So again, we're not going to do anything with the top, 3m to the 8th, n to the 12th. What happens to the m's in the denominator? M squared cubed becomes m to the 6th. You're exactly right. We multiply those exponents. Then when we have n cubed cubed, one base with 2 exponents, we multiply again, so n to the 9th. So now we want to combine the top and bottom. You've just got a 3, so the 3 stays. M to the 8th divided by m to the 6th.
2.
M squared. Yep. And then n to the 12th divided by n to the 9th is going to be n to what power? 3. And then you've only got one number and one of each letter with one exponent to each one of them, and we know we're done.
Done.
And then we're done.
Today? What?
Okay, there are 10 problems like this. I did set it up so this won't be due until the 18th, which is not this coming Monday, but the following Monday,
But they are open.
so that it is open right now.